So nCloth works under the nucleus node, so it can interact with n particles, which is a great benefit sometimes. It's also beneficial because the things you learn for n particles still apply to nCloth. So let's make something really simple. We'll make a plane and turn it into a page that we can turn. So we'll just create a polygon plane. So these only work on polygons, not on NURBS. Not that we really use NURBS for too much anyway, but it has to be polygons. So I'm just going to give this a little more, some more divisions, because this has to have divisions to act upon. So essentially what's happening when you turn something into an nCloth is that each vertex kind of turns into an n particle that's connected by their edges. And so they can act dynamically. And so it acts like a cloth, but you can change it to act like something cloth-like paper or whatever. So I'm actually going to give it a little more, maybe give it 32 divisions in each dimension. And I'm just going to move it above the ground slightly, or above the ground where the ground plane would be. The other thing you want to do before you apply an nCloth is delete the history, because there's a lot of calculation to do as it is, and freeze the transformation. Okay, so to make something an nCloth, you simply do the same thing like when you did particles, but you've got an object selected. You go to nCloth and create nCloth. If you open the options, you'll see there's nothing except for which solver you want to use. And here we have no solvers, so it's going to create a new solver. And again, solver means the nucleus node. And you have to be on play every frame like usual for any dynamic system in your preferences. And if I play this, it should just fall, and it does. So if we look at what's going on here, we've got our polyplane that we first created and an output cloth. So what Maya is doing is it's keeping the original object and then making an output cloth based on the settings that you put into this other node called nCloth shape. And then it's evaluating within the nucleus node settings, which are the settings of the environment in which it exists, right? So the first thing we can do is say use plane, and this is in the nucleus node, and now it will fall and just hit the ground. So that's one way to stop it from falling. So it's got something to collide with, this imaginary ground. But there are other ways that we can do this too. We can use what are called n constraints, and we're going to look at some different ones here today. But this has been turned into an nCloth, and if I just right click and go to its vertices, let's say I select all the vertices down one side. Now I can create, so here in my, down here the second last line of my hotbox options, there's n constraint here, and I'm just going to tear off this panel. And we're going to look today, I think, at a slide on surface, maybe a terrible constraint, not terrible, but terrible, if you know what I mean. There's transform constraint, point to surface, slide on surface, different things. But right now we're going to look at it, just add a transform constraint. So what a transform constraint does is just lock the vertices we have selected in space. So now if I play the animation, if I turn, I'm not sure if I turned off that ground plane. Yeah, I did. So it falls, but those ones that we have locked in space stay locked there. So if I go back to my nucleus node and turn off the ground plane, so use plane, turn that off, and rerun my animation, so it will just fall and hang here. Okay. So we're getting somewhere. So if we wanted to make paper, this could be the edge binding that we want to use, right? So I'm just going to get rid of that dynamic constraint for now. I'll put it back on later. I don't want this thing falling and just landing on the floor each time I run the animation. So the best thing to do is to select it, run the animation, then freeze it in that spot, so it always starts already on the floor. So if I just run the animation, oops, I turned off the floor, turn that floor back on. In the nucleus node, use plane. So run the animation, it falls, stop the animation. And then we talked about this before with particles, but we can go to the fields and solvers menu set. And down here, partway through, we can say for initial state, set for selected. So that's the state it will have now at the beginning of the frame run. So now when I play it, you see it doesn't fall down at all because it's already sitting on the floor. If you ever want to get rid of that, you can just go back to fields and solvers, initial state, and clear initial state. Okay, so let's make this page turn. So first of all, we want to lock down one edge as the binding, so we'll do that same thing again. I'm just going to right click and go to vertices and select just the vertices along one edge. And again, use a transform constraint. So now if we play the animation, nothing should happen because it's still on the floor, it's got nowhere to go. So before we start animating it, let's look at the qualities of this paper. So if we select the nCloth, and I'll just, oh, I can't do that. If I just tear this off, here. In the nCloth shape, if you click on the presets button here, there are a number of presets built in already. So there, let's say there's something like silk. So what is silk like? It's slippery, it's low friction, right? The Mongols used it as armor for arrows because it doesn't stretch at all. It's very rigid in that way, but it's flexible. So if we go to silk and replace, let's look and see what it's changed here. So just like particles, we've got collisions, so we can collide and self-collide. Got the thickness, same as particles. We've got bounce, same as particles, friction, stickiness, and so on. So difference between friction and stickiness, friction is more tangential, so it stops it from sliding on the surface. Friction is, it's stuck to a surface if you try and pull it away. Friction isn't affecting it, but stickiness is. You try and slide it on the surface, friction is affecting it. So then we've got stretch resistance, so you see compared to something like compression resistance, it's quite high. So if you think about silk, you could take a piece of silk and crumple it into a ball, but it doesn't stretch very much, it's not rubbery. So you've got bend resistance, so this is bending on a single angle rather than compressing, crumpling together. You've got this thing called restitution angle. Oh my God, you all right?
Yeah.
That's worth 3, whatever that was. You can sneeze. Okay, let it out. So something like this, restitution angle means how much it has to bend or be deformed before it won't return to its original shape. And silk should always be able to return to its original shape. But if we change the preset to something like, what is it, sheet metal, I think. Yeah, soft sheet metal, not sheet metal, sheet metal. Replace that. You see it's got a very low restitution angle, so if you banged sheet metal with a hammer and it got a dent in it, it's not going to pop back into its shape. Then you've got rigidity and deform resistance. Now, these are kind of contrary because they work in conjunction with, so you can see sheet metal's got a high stretch resistance and compression and bend resistance. So it's hard to bend, but when it does, the restitution means it will stay in that shape. And then you could control its rigidity and deform resistance this way. So you can see, even though this is sheet metal, you want it to be able to bend, but it takes a lot of force to do it. If we look at a preset like concrete, you see it's got a rigidity of 4 because it's not going to bend without breaking. So that's kind of the difference here. And then there's loads of other things. So you've got its mass, you know what mass is. Then you've got its lift, so how much it's going to react to the air density. Drag, how much it's going to resist moving through air. Damp is just an overall controlling of its dynamic motion. So if we want something to be paper-like, so let's just go back to something like t-shirt material, I don't know. We want to turn up, we don't want paper to be able to stretch, so we can give this a high number. We don't really want it to be able to compress either, I think. Give that a high number. So let's just try that. High stretch, high compression resistance. And how do we animate something like nCloth? Well, you can put a field on it, just like with particles. So if I go to fields and solvers, and if I put a, let's say, a turbulence node on this, let's see if it works. So you can see it's causing the surface to deform. And it's shifting through here slowly. So you can animate it that way. You could put something like a wind on it, see if we can make it move. I don't know if it'll work, so let's try. So you can either make a wind field, or you could go into the nucleus node and turn on wind. So you've got wind speed, if I turn that up, and the wind direction right now is in positive x, so if I make that negative x, negative 1 in x, I don't know if this will work. It's lying flat on the ground, so there's nothing to really pick it up. So I think if I put some turbulence or noise on that, it might work. It might not, actually, because it's so perfectly flat. Okay, there we go. So you can animate it that way, so you can make a flag or something. But another way we can work with this, let me just turn my wind speed down, is to make another constraint. So we could select some vertices here, just in the corner. Let's say you want fingers picking it up to move it, and make a transform constraint. And I'll show a better way to do this. We'll just do this, we'll take a break, and then we'll look at another example. But if I go to end constraint, transform constraint, now I can animate this. And we'll look at the qualities of the constraint itself in a minute. So I'll just key, oh, she's a-crashing. Why is that? Well, luckily, I already have it built. Okay, so let me just open a file and we'll look at it, and then we'll take a break and we'll come back to it. So, just open the scene. So you can see I've got the same thing down here. I've got my little transform constraint in the corner. If we play the animation, I've already animated this. So animating is just moving it into different positions, sending keys on translate. But you can have the page turn, flip over, and you can do something like this. We can render this out. So, and then on one side we've got this man, and if we go back to the beginning, got his other side there. So we'll look at setting that up too. And the last thing I'll do, let me just change some of the qualities of this paper. So for example, if I go into the nCloth shape node, and under the collision properties, stickiness is at 0 right now, but if I change that to 1, for example, that'll make it quite sticky, I think. Oh, no, it's not. Let me change the dynamic properties. So my stretch resistance is very low, is very high. So if I change that to something very low, like 1, so you can see the stickiness is kind of being felt more now, because before it couldn't stretch at all, so the stickiness wasn't influencing it. But here with the stretch resistance much lower, you get a very different type of animation. So the real benefit here is that you can experiment with the type of animation that you want without having to re-keyframe everything. You're just changing the qualities of the object that's being animated. Okay. So we'll take a break now, but are there any questions first? Yeah.
Why do you have to put transform constraints on performance?
Well, because the constraint is the only way to grab the paper. Like, the one thing you might think about doing is, like, if you, let's say you had an animated hand, you could put collision objects and use it to try and grab, but it's got to solve all these collisions each time, and it usually doesn't work well. So you just need something to be able to grab a piece of it. What we're going to look at when we come back from the break is this scene. So let me just open this and you can see. Where is it? Oh, I don't have it here. We'll have to look at it. But we're going to look at a way where you can have an object move around and just grab different parts without locking to a single part, using a surface to a component to surface constraint. So we'll look at a different rig for doing that. Okay? Okay, so let's take a quick break for like 10 minutes and then we'll start again on nCloth.